My name is Marcel. I'm a director for our solutions consulting team here in Asia. So all of our solution consultants, technical account managers, and so on. And today I'm going to talk about Kubernetes and what I think is the next generation of autoscaling in Kubernetes. We're going to take a look at what exactly is autoscaling and why should we use it, how does it work under the hood, what I think is the next generation of autoscaling, how can we implement it, and I'm also going to show you a little bit of a demo of that. But before we get to that, before we start, I'm going to have a short quiz. Please raise your hand if you're using Kubernetes. That's a lot. Keep your hand up. Okay. Keep it up if you're using it in production. Wow, that's almost everyone. Awesome. And keep it up if you're using it with autoscaling. Wow, that's quite a lot. That's amazing. So probably don't have to tell you too much about what autoscaling is, but let's do it anyway. So the definition of autoscaling is pretty straightforward. It basically enables you to scale up your resources only when it's needed. Right? When you have a lot of traffic, for example, coming in, scale up the resources, and then scale it back down when that traffic subsides. Without autoscaling, most teams actually run at 60 to 80% idle capacity. And I'm sure you've seen that in the more traditional world where we provision servers and most of them run at a lot of idle capacity. Whereas teams, generally, they would only need half the amount of resources. But to understand why this is so important, autoscaling, we also have to understand and look back at where we're coming from. So back in the Stone Age, as a number of servers or instances grew, you also had to scale your organization. Because people went out, they would manually provision servers, or they would have to write cloud provider specific scaling scripts, custom automation scripts, and so on and so on. Scaling always required a lot of careful planning. Right? You had to take a lot of things into account, talk to a lot of different teams to get the resources that you need. But then along came Kubernetes, and it made it so much easier, right? You would go in, and the developer would say, kubectl scale, bam, give me 100 replicas of this application. However, that comes with a set of new challenges. Now we have to consider things like the node sizing, the pod sizing, the number of replicas of these applications. We have to consider things like persistent storage in Kubernetes, the limitations on the network, and so on and so on. So in order to make the right decision around the scaling, what we had to do in this case was observe the environment over time and make adjustments manually, right? To not have to do that, we have autoscaling, right? So autoscaling really helps us to make a lot of these decisions automatically. It helps to avoid the under or over allocation of resources. Because under allocation can lead to a lot of problems, like out of memory issues, CPU starvation, pod eviction, and that in the end leads to a bad user experience. And that's what we all want to avoid, because if the user experience is bad, the user is going to go somewhere else, right? However, on the other hand, the over allocation would usually lead to a lot of financial waste, which is also something we don't want, because then our boss is going to be angry with us. So in Kubernetes, there are different types of autoscalers. We have a cluster autoscaler, which can add or remove nodes to your Kubernetes cluster, and it makes those decisions based on the resource utilization within that cluster, or based on the resource utilization on those nodes. Then that is ultimately important, because without having sufficient resources available in the cluster, none of the applications are able to scale, right? Then we have the vertical pod autoscaler, which can add or remove CPU and memory resources to existing application instances. This is also usually based on resource utilization. And then we have the horizontal pod autoscaler, which can add or remove replicas to or from scalable controllers, like the replica sets and so on. And that is based on resource utilization or user-defined metrics. And we're going to take a closer look at each of these three types of autoscaler and how it works under the hood. So this is a very simplified diagram for the cluster autoscaler. So basically what happens if you have a pod that is in pending state, or you have a couple of pods in pending state, the Autoscaler will request nodes. Usually that happens by requesting them through a cloud provider API. Let's say you're running on Amazon or on GCP or on Azure, or you run in a local cloud, OpenStack, VMware, whatever. So the Autoscaler would request new nodes from that API. These nodes would get provisioned, and then the scheduler is able to schedule pods on those nodes. So we're not going to go into too much detail on the cluster Autoscaler, because scaling the application is ultimately the more important part. So what is the difference really between the HPA and the VPA? So as you can see, the HPA scales by adding or removing pods, so it scales horizontally. You can see before there's one pod, and now we have 3 pods. The VPA scales by scaling vertically, so it just adds more resources to that existing pod. So under the hood, the VPA consumes metrics and certain events from the Kubernetes metrics API and the API server. Then we have a VPA spec in which we define some settings around the parameters that we want to scale based on. And the VPA will make a recommendation. And then we can decide whether or not we want the VPA to automatically implement that recommendation or not. If we have it set up that way, then the pod gets recreated with these applied changes. However, the VPA is not quite production ready, I would say. There's a lot of caveats to it. It can only scale based on CPU and memory. It cannot scale any stateful applications, like your stateful sets, so it can only really work on replica sets or deployments. It doesn't really know how to handle things like JVM memory and so on and so on. So generally, the recommendation would be to use a horizontal pod autoscaler. Similar to the VPA, the HPA consumes metrics from the metrics API. It then compares the metrics with a target that we have, or that we have to set up. If it's greater than the target, then it will scale up more instances of these scalable controllers, like your replica sets or your deployments, which will then cause new pods to get scheduled and run in the cluster. So the HPA can consume different types of metrics. The built-in ones in Kubernetes are just CPU and memory. That's a built-in metric. That's just resource metrics. So that's based on whatever your application consumes in terms of CPU and memory. Then you have a custom metrics API where you can add custom metrics to Kubernetes around that application, around those Kubernetes resources. That could be latency, throughput, QDEF, and so on. And then you have external metrics, which are also completely user-defined, similar to custom metrics. But these can be metrics about Kubernetes resources, or these can be metrics about other things, right? For example, the number of unique clients hitting your load balancer frontend. But which metrics should we look at? And to know that, we have to kind of look at what kind of common bottlenecks exist in an application, right? So we could have CPU bottlenecks, memory allocation, or even memory bandwidth, storage throughput, storage latency, networking, and so on and so on. Thread contention, backend dependencies that may not be obvious, if you just look at it. So in order to, use those kind of metrics for autoscaling, I think what we need is the next generation of autoscaling. And in my opinion, that is, if we're combining the power of New Relic APM with the power of Kubernetes autoscaling, that's when we get there. That's when we get something that's more than the sum of their parts. This is how it works. So the part on the right, you've already seen, right? So we got the horizontal pod autoscaler there, we got the scalable controllers and the pods, and the metrics API. But now, in addition to the metrics API, we also have an external metrics API. So New Relic, recently we released the Kubernetes metrics adapter, which can then talk to our nerd graph API. And basically, any kind of NRQL query you can use in this adapter, and then make scaling decision based on that. So how do you do that? How do you go about doing this? It's fairly simple. The first step is we define our NRQL query. What kind of metrics you want to look at when we scale. This is an easy example. Here we're taking a transaction duration for the last minutes. We take the average of that for a particular application, right? That's the query you see right there. We configure that in the metrics adapter configuration. That's done via a configuration parameters file for the Helm charts. We apply that configuration via Helm, And then we create an HPA object. What does the HPA object look like? What does it contain? First of all, it defines the application that we want to scale. It defines the minimum and maximum replicas that we want to have for that application. It defines the metrics type to use. So this could be more than one metric, right? And whichever metric which cause the biggest scaling event is the one that the autoscaler will pick. In this case, it defines the name. You can see the name, that's the front-end duration. That's the same name we gave it earlier in the configuration. And the value, in this case, is 0.15 seconds. So what metric should you use? That was just a very simple example, average transaction duration. That really depends. That's always a bad answer, I know, but it's always true. Because very application specific. Different applications have different types of bottlenecks. The most common practice, as I mentioned, is just using CPU memory. But there may be cases, for example, where the developer forgot a sleep statement in the application. The CPU utilization is really low of that application, but the throughput is still bad. So if you scale on CPU utilization in that case, it's not going to help you, right? So we got to look at metrics that are really relevant to the user experience. So is CPU utilization relevant to the user experience? Not always, right? The number of transaction or transaction duration and so on, is probably more relevant. So I'm going to show you a quick setup. I have a quick demo of that. So in this setup, in this example, we're running a Kubernetes cluster that is instrumented with our New Relic instrumentation. Within that cluster, we have 3 microservices. We have a front end, we have a parser, and we have a worker service. All of these are instrumented with New Relic APM. Then we have a couple of load generators, a message queue, and a database. So one of the load generators posts some data onto the front end. The front end posts it to the parser. The parser pushes it into the message queue, where it gets picked up by a worker. The worker then puts it into the database. That's the posting of the message. And then getting of the message is fairly simple. We have a load generator that just talks to the front end, which then talks to the database and gets a message out. Really simple. It's like a simple guestbook application or something like that. So the first use case we're going to look at is we want to scale based on that average transaction duration, right? And as I mentioned earlier, that duration may be high even when the CPU utilization is low. So I'm going to show a quick demo. So as you can see, we have an application running here. We got a front-end latency of like, 50 milliseconds. We have a pretty good AppDex score. And now we're scaling up the load generator to 10 replicas. Immediately, we can see that the average duration of those transactions goes up. Our AppDex score drops. We have a lot of throttling here. There's a bit of increase in the database CPU usage as well. And now we're applying a very simple HPA object. And then we can see that the front-end latency goes down again. You see we have a lot more instances all of a sudden of this application running here. And the CPU utilization of the database goes up significantly to like 50%. That's because now we have 20 replicas hitting the database. When we scale back down again, the reverse thing happens. Right? It takes some time, and then the autoscaler will basically scale back the instances that we just spun up to an amount that is appropriate to service a request in the time that we wanted to. So now it's at 8. If we would have waited a little bit longer, it would have gone down even further. It's fairly simple, but this is how it's done. And this is similar to the transaction, the query I showed you earlier. We just look at the transaction. We look at the average duration for the last 2 minutes. And then in the HPA object, we define a value. In this case, it's 100 milliseconds. You can also use the AppDex score, for example. Right? This converts the AppDex score into a value from 0 to 100, which is what how the HPA works. Because the higher, the worse. So we have to kind of convert it. But basically, this takes the AppDex score. This says we want to have an AppDex score of at least 0.9 in this case, so because the value is 10. And it will make a scaling decision based on that AppDex score. I don't know if you're familiar with AppDex, but it's a way of measuring the application performance. That's all nice and well, but you saw that this database utilization went up to like 50, 60% almost, right? What if we also want to take into account some downstream dependencies? What if you don't know if your database in the backend can handle that, those additional front-end instances? So in this example, we really don't want to scale the front-end if the database is saturated to a certain degree, right? And this doesn't have to be a database, this can be other things as well, other downstream dependencies. So I'm going to show that as well. Same scenario, right? So we're scaling up the load generator. We see on the bottom right is a database CPU utilization. We see the front-end latency goes up, right? The AppDex score is horrible. Users having a bad time. And now I apply somewhat more complex HPA configuration. And you can see now that the front-end latency is slowly decreasing again. The AppDex score is slowly increasing again, which is a good thing. But you see it doesn't happen abruptly. The database utilization doesn't shoot up to 50, 60%. It kind of stays stable at this 29% now. Even though the latency is not less than 100 milliseconds, which is what we defined, right? So how does this work? This is actually a somewhat more complex query, right? Where we're looking at the database CPU utilization, and if it's less than 20%, as well as we're looking at the value for the front-end latency, right? So we're looking at the database. If it's less than 20% utilized, then we actually scale up. If it's more than 20% utilized, then we don't add any more instances to this. And I think you can kind of understand or see where this is going, right? Because there are a lot of things that you can scale based upon. You can set up New Relic synthetics, get some of the data from there, scale based on that. Data from Pixie, so you write your custom eBPF script, get the data from there. Timers in an application, your queue depth, number of connected users, cache hit miss ratio, right? All of these things. Any kind of custom event that you can push into New Relic, you can make a scaling decision based upon, right? For example, I had a customer who was talking with me, and they have some kind of batch processes running. And when the batch processes hit the first system, they already want to scale up the backend systems that will then the processing, after this batch process has been split up into 20 other, right? So they don't have to, so they can do it proactively, right? And go through this batch processing faster. You can use a built-in golden metrics that we have in New Relic, any kind of application status code, right, that you put in your application, the number of log lengths ingested, really, whatever you want to scale based on. Published messages in a message queue. So if you exceed a certain number of messages in a message queue, or if the queue depth is getting longer, then you scale up some worker to pick up the slack, right? Number of alerts, even the temperature in your data center. Like if your data center is on fire, don't, cause a lot more new stuff to spin up. Or the moon phases, if that's somehow relevant to your business. Maybe it is, maybe it isn't. So anything really that you can query, you can scale based on. And I think that's kind of the power of, combining APM, New Relic APM, with Kubernetes autoscaling.